Hey guys, this is the stoichiometry unit, so we want to go ahead and get started. The very first thing we're going to do is define stoichiometry. Now, this is a very wordy definition. It's the study of quantitative relationships. If you'll remember from Unit 1, quantitative and qualitative were two words that we learned, two of our vocabulary words. Qualitative meant something that couldn't be measured, like color, things of that nature. Quantitative were things that could be measured. So it's more things that can be used with numbers and measured in numbers, like height, mass. All those are quantitative. So this is the study of quantitative relationships between the amounts of reactants used and the amounts of products formed by a chemical reaction. An easier way to state this is just, if I have a certain number of reactants, how many products can I have? Or if I've produced a certain amount of product, how many reactants did I have to have? And so that's what it really means. Now, stoichiometry is based on the law of conservation of mass, just like we've been talking about before. Now, from our balanced chemical equations that we have already learned how to do, you can actually derive some different relationships, and you have to be familiar and be able to write all of these relationships down. Now, you have to make sure when you're given a chemical equation, you have to make sure it's already balanced. This one is, so you don't have to worry about this one, but make sure the first thing you do is always make sure it's balanced, and you may want to jot that down in your notes. Now, if you look, we have 4Fe plus 3O2 yields 2Fe2O3. The first thing I can do is I can write it in names in the word equation. So as you're drawing this chart, you need to draw the chart in your notes, and as you're drawing the chart in the notes, label it as word equation. So this would be iron plus oxygen gives us iron 3 oxide. As you can see, this is using the stuff that we've learned in other units and using them again. Now, the next thing that you can do is you can tell the number of atoms or molecules or particles that each reactant and product has. The coefficient in front tells you how many they have. Now, if you'll remember, if you have a metal, they're going to be called atoms. If you have a nonmetal or a covalent compound that is made up of only nonmetals, you use molecules. And if you have an ionic compound that's a metal and nonmetal, you use formula units. So that's where those words come in. So you have 4 atoms of iron, 3 molecules of oxygen, 2 formula units of iron 3 oxide. Again, to tell how many moles we have, you use the coefficients. Okay, so the coefficients are very key in most of this. So this tells me, the coefficients tell me that I have 4 moles of iron, 3 moles of oxygen, 2 moles of iron 3 oxide. Now, since we know how many moles we have, we can determine how many grams we have. And if you'll remember, you take the number of moles and multiply it by the grams that's on the periodic table to give you the grams of each element. So as you can see, you have 223.4 grams. The reason you have that is because you took the mass of iron and multiplied it by 4. You go to oxygen. You have 96 grams of oxygen. The way you calculated that was you had the mass of oxygen, which is 16 times 3. And then you can go and you can calculate the mass of iron 3 oxide, and you can multiply it by 2 because there's 2 moles of it. Now, the reactant masses should equal the product mass. So that's a way you can kind of check yourself to make sure that you did everything correct. Now, what I'm going to do is I'm going to now show you this, and I'm going to write out the different ways that we just did this so that you can also add it to your notes. Okay, for this first one, this is the word equation. So that's how we're going to refer to it, as word equation. Make sure you know that. This tells you the number of particles you have of each reactant and product. This tells you the number of moles you have. And this tells you the number of grams you have. And like I said, this chart should be written in your notes. You need the example of it because you're fixing to do some practice on your own. Now we're going to do some practice on your own. I'm going to read the problem, then I would like you to pause the video, try it on your own, and then resume the video to check to see if you're correct. The combustion of propane, and propane is C3H8, provides energy for heating homes, cooking food, and soldering metal parts. Interpret the equation for the combustion of propane in terms of representative particles, moles, and mass. Show that the law of conservation is observed. And guys, I'm going to add in the word equation. I want you to do the word equation also. So you're going to do the word equation, the number of particles, the number of moles, and the mass that you have. You have the chemical equation down at the bottom, and I'll go ahead and tell you it's already balanced, so you don't have to worry about that. So go ahead and make you another chart and fill in your chart and see how well you do. Pause the video and resume it once you're ready to check your answers. All right, these are your answers, so check them. If you didn't get something right and you're not sure why, make sure you circle it or put a star next to it so you can ask me in class. Now, let's go ahead, and you have to be able to do this. You know, like I said, you need to be able to do each one of these steps. Now, let's go ahead and talk about mole ratios. As we talked earlier, the coefficients tell you how many moles you have. So those coefficients indicate the relationships between reactants and products. Let me go back and show you what I'm talking about. On this formula right here, I have 1 mole of propane. Oh, and you know what? I realized there was a mistake on this. This right here should have 1. And hopefully the rest of it's right. If it's not, you guys let me know when you get to class. All right. So we have 1 mole of propane, 5 moles of oxygen, and 3 moles of carbon dioxide, 4 moles of water. That means 1 mole of propane, I have to have 1 mole of propane to make 3 moles of CO2. Or I have to have 5 moles of oxygen to make 4 moles of water. Or I have to have 5 moles of oxygen to make 3 moles of CO2. So those coefficients give you the mole ratios and help you know the relationships between the reactants and products. Now, the definition of a mole ratio is the ratio between the numbers of moles of any two substances in a balanced chemical equation. Remember, again, you have to make sure your chemical equations are balanced before you start these processes. Now, to determine how many mole ratios a chemical equation will have, you take the number of substances and you times that by the number of substances minus 1. So if I have 4 substances, then the number of mole ratios I have, it would be 4 times 3. That means I have 12 mole ratios. Okay? So, for example, here's one that has 3 substances. Right here, KClO3, that's one substance. KCl is another substance, and O2 is a substance. So if you go back to our formula, you take the number of substances, which is 3, times the number of substances minus 1, that would be 2. So you say 3 times 2 means I'm going to have 6 mole ratios. And I believe that's what we have. Now, a mole ratio is simply this, telling how many moles you have of something to another substance in your chemical equation. We'll start right here. 2 moles of KCl3, I have to have that to create 2 moles of KCl. And you see the 2 came from the coefficients in front of them. Let's move to the next one. I always stay with the same substance, so we'll say then 2 moles of KClO3 is related to 3 moles of O2. Okay, so now we've completed KClO3. Let's move to KCl. 2 moles of KCl is related to 2 moles of KClO3. 2 moles of KCl is also related to 3 moles of O2. Now we move to oxygen. We have 3 moles of oxygen is related to 2 moles of KClO3, 2 moles of O2. I'm sorry, I'm wrong again. This should have 3 moles. So 3 moles of O2 is related to 2 moles of KCl. So there are 6 mole ratios. When you have a mole ratio, it's just one substance, how many moles you have to another that you have. And the equation has to be balanced before you can make these mole ratios. All right, that's the end of the video for today. What I would like you to do is I'd like you to do your summary at the bottom of your page. And I want you to write a note to an absent student that didn't get to watch the video explaining the most important parts of the video. I hope you have a great evening, and I will see you in class.